A mechanism is an assembly of multiple parts designed to accomplish specific motion tasks. In engineering applications, we require mechanisms that can generate complex motion while bearing heavy loads. In this paper, we present multi-point conjugation gear mechanisms abbreviated as mpcGear for generating a user-specified 3D motion. An mpcGear consists of three mechanical parts: a driver gear providing a 1 degree of freedom rotary motion as input motion, a follower gear performing an output motion, and a support holding the gear pairs. Our approach. Given a user-specified 3D output motion, we first model a pair of open 3D conjugate curves with augmented normals as a tooth pair that generate part of the output motion from the 1 degree of freedom input motion. The tooth pair keeps contact at the conjugation point. We then combine multiple tooth pairs and model a subgear pair that generate the full output motion. Next, we model K subgear pairs to maximize the measure of dynamic form closure. We model a multi-point conjugation joint by sweeping a cross-section along each open 3D conjugate curve to form a pair of conjugate surfaces with multiple conjugation points. And then we add spokes and a central hub to each conjugate surface to form the driver gear and the follower gear. Finally, we add the support, the driver support joint, and follower support joint. Results. Our approach can model various mpcGears generating motions in different motion spaces, including 1 degree of freedom rotation, 1 degree of freedom rotation and 1 degree of freedom translation, 3 degree of freedom rotation, and 3 degree of freedom rotation and 1 degree of freedom translation. Experiments. To evaluate the kinematics of our mpcGear, we modeled an mpcGear 3R to generate 3 degrees of freedom rotation and then visualized the motion using a sphere with 2 arrows. And we 3D printed this model and tracked the path generated by the sphere from the front view. The tracked path and the poses of the arrows over time are very close to their virtual counterparts. We compare our mpcGear with the mpcMech on the same motion in 3 degrees of freedom rotational space by modeling both mechanisms, and evaluate their load-bearing performance using their 3D printed prototypes. The mpcGear continues to generate the motion under higher loads without losing contact. Applications. We demonstrate the use of our mpcGear as a low-cost manipulator for pick-and-place tasks involving heavy loads. And we fabricate this model with 3D printing and added a load of 800 grams. And our mpcGears can be used in the flapping wing mechanism to generate flapping motions. Thank you.